Hey everyone, Jeff here. On today's episode of MCEP Tech Tips, we're going to talk about power supplies. So, one thing that we need to probably address is, what is a power supply? So, oftentimes when you talk about power supply to probably a new student or a new person that's dealing with technology or electronics, they think to themselves, oh, well that's just like a transformer, and you'd be close but not quite. So, in a technicality, you're going to find that in a power supply, you're going to have that transformer, but then you're going to have basically a bridge rectifier that's going to transfer that from AC current down to DC. So the transformer is going to step it down to the voltage that you need. The bridge rectifier is then going to convert it over. And then there's also going to be a capacitor and some other stuff to help filter it out so that it's more of a pure straight DC rather than kind of a fluctuating DC that's still coming off that bridge rectifier. We could probably get into a lot more of the components that are inside of that, but that's going to take a lot longer than just explaining the power supplies that we're probably going to go through today. So, asking that basically, so then we need to address the next step of, well, what size power supplies do we make? So, well, then that brings us to the next question of realistically of like, well, what's your input power? So is your input power going to be like a single phase, or is it a three-phase power supply? Well, that depends on what kind of power you have in your electrical cabinet that you're feeding your system with. You'll find a lot of them that are single phase. You'll find a lot that are three-phase. You'll find three-phase power supplies that are 120, 208. You'll find some that are 480 volt power supplies. And then you can even find some that are upwards of 600 volts. Generally, anything higher than that, we're talking really heavy industrial grade. You don't see those in too many lower manufacturing facilities. A lot of them you're going to see are going to be like the 208 three-phase or the 480 three-phase. The benefits to the three-phase power supply over like a traditional single-phase is you can have a higher output current. So that we'll probably talk about a little bit more, but your higher output current is sometimes definitely a beneficial selling piece to certain power supplies. With that being said, that's going to be your input power that you need to determine is your voltage. Along with that, you need to determine what your current rating is. So again, it goes back to what kind of current can you give it. If your cabinet is pulling 480 direct load into your electrical cabinet, it's probably advisable that you go ahead and go with a 480 three-phase power supply rather than using a single-phase power supply. Why? Because now you're adding a piece of equipment onto that cabinet, which is going to be a transformer. So you're going to step down from the 480 down to a single-phase power supply, or, excuse me, down to single-phase from that transformer to 120 volts into that little power supply that's going to then run your system. Where you could have done away with the transformer or away with that current load that you need from that transformer and gone ahead with just a straight power supply off of that load. Kind of depends on what your current need is. It really does. So your current is going to matter both on your input into your power supply and your output of your power supply. So what is your current demand that you need on your DC load? So if you're using 24 volts DC and you're going to say, hey, you know what, I've got this component, this component, this component, they're all going to draw about an amp. So now you're saying, well, I need roughly about 3 amps. Okay, so let's go ahead and step that up to the next set that they kind of have that's about 5 volts DC. So that's the load that we're going to spec for. So then we're going to say, okay, well, what's our demand for a 5 volt DC at 24 volts? Obviously, you're going to use your Ohm's law, so P equals I times E kind of thing. You're going to figure out your wattage, and then you're going to go over to your, basically convert that over, and that'll give you kind of your needed input demand current. So that way you can spec out your breaker to go into your power supply. Or you can spec out what you need for that transformer if you're going to go ahead and go that route, or you can spec out what your fuse load is on your incoming power too, or your breaker load for your incoming power. So realistically, that's what determines what you need for power supply, quite frankly, is what is your current demand and what is the voltage rating that you're looking for. And obviously, like your input, it's always going to be like, well, what kind of power am I working with? Am I working with single phase, three phase, and what voltage rating, obviously, once again. Now, back to the other output again. So there's output voltages that vary. Oftentimes we use in a manufacturing environment in control systems, it's always going to be about 24 volts DC. We are starting to see more and more of the 5 volts DC control components because we're starting to see more and more of the Arduino and Python, Raspberry Pi stuff coming into the applications, into the world of industrial automation. Why? It's open source. It's a little cheaper to run that stuff, and quite frankly, it works really well too. So that brings us to that we need a 5 volt DC power supply basically, and we are seeing more and more of those on the open market ready to be purchased. We did see those in the past as like a TTL input module that we would see in like a Rockwell control component or something along those lines, or even like a 12 volt DC control component, once again with a Rockwell specialty module. They were used mainly for specialty sensors or specialty thermocouples or something along those lines they were a very specialty part that had only that need right there. Some of them were actually encoder control components. So your encoder would actually send back a 5 volt or a 12 volt DC current load. So it'd be a high speed solid state input module. Just kind of depended on what you really needed there. But now, like I said, we're starting to see it more and more with the Arduino and the Raspberry Pi setups and stuff like that. And then even the integrated PLCs that are working with both of those control components. So again, we've talked about the 5 volt DC, 12 volt DC, and a 24 volt DC. We are starting to see some of the 36 volt DCs. They're kind of a specialty thing. You don't really see very many of them. It's generally a specialty component. And then there's even a 48 volt DC. And now 48 volt DC has been around for a long time, because it's the control component that most of your landline telephones use, was 48 volts DC. So that's been around for a long time. In the controls world, yeah, it's your power over ether kind of communications power line. So yeah, it's around. It's not real popular still, except in the power over ether market. Other than that, that's kind of it, really. We do see some that are in like a 90 volt DC, but they're very, very specialty modules. It goes back to, like I said, traditionally everything's a 24 volt DC, and then you'll see it lower than that, in fact. But that's really what your power demand is. So it just kind of depends on what again, goes back to what I said earlier. What is your need for voltage, and what is your need for current demand of that particular application? You'll have to sit there and go through your speculations and your calculations and stuff to figure out what you need. And if that's something that you think we would need, let's make a comment on that, or give me a thumbs up and say, hey, we need to go through, like, how do you calculate that stuff on a daily basis, or what is it that you use for a formula? And I'd gladly go over some of that information. There's a lot to it sometimes, and there's a lot that's generally common sense that you could, you just have to read about what you're putting on your lines and stuff like that. So before we end this video, though, I have this power supply that I want to go over real fast. So obviously, generally, on the side of the power supply, you're going to have whatever your output and your input loads are going to be. And then, obviously, your voltage ratings, your current ratings. And sometimes they'll actually just tell you what your power rating is. And then, obviously, like, are we 50 or 60 hertz? Can we run on both? And in this particular case, I have a Wiedmuller power supply. And it just happened to be one that I had readily accessible. And I'll be honest with you, I use all kinds of different brands of power supplies, so I don't have one that I prefer. Again, just one that was laying around that I happened to grab. But this particular one is a 120 volt input, so basically it's a single phase input. As you can probably see that I've got a single phase connection going into it. And then I've got a 24 volt DC coming out of it, and then it's a 3 amp power output, basically. So, or current output. So that's what this little guy right here can handle. But on most power supplies, you're going to notice that, and hopefully I can catch this on the camera here, you'll have basically the positive and the negative terminals that you can use, and then you'll have like this little normally open switch. And what that basically is so that you can wire into your PLC saying, hey, you know what, the power supply is good and we're running, because that switch is going to close while that's like that. But then it'll open when the power supply is dead, turned off, or not working properly. So it's kind of handy if you want to know what's going on with your current, your power supplies, etc. Particularly like if you're using this for like an output control module. So sometimes in a PLC controlled environment, they'll have maybe like all of your outputs are on one power supply, all of your inputs on another power supply, and then all of your other little minor control stuff's on a different power supply. And that way it helps isolate some of that stuff a little bit, and then they just tie all the commons together, so that way, you know, nothing's really lost in there. And then sometimes you won't see that. Sometimes they'll have one massive power supply and it controls everything. It just depends on who designed it and what their goals were. One other thing, too, I wanted to talk about is there's a little set screw right here. So this little set screw allows you to adjust it from 22 to 28 volts on this particular power supply. So sometimes they don't always put out the exact 24 volts DC you're looking for. And so what you want to do when you first get that power supply and you first hook it up, you're going to want to take your little your multimeter, hook it up to it, and then you're going to want to adjust that screw until you hit right at that 24 volt DC. My next suggestion is, after you put this power supply into your control cabinet, you power it up and everything, make sure that you're not getting a lot of voltage loss. Sometimes you can get a voltage drop across a load of some sort or whatever, so you want to adjust that up just a little bit so you're right on that money at 24 volts DC. Just a helpful little tip. Most components can run between 20 and 28, 29 volts, and you're not going to worry about frying them or having any problems. But there are some control boards that are very, very sensitive to that voltage drop and that high end, and you'll shorten the longevity of that control board, or you'll fry it. So just something to keep in mind. Definitely when you're wanting to install a new power supply into your control cabinet. That pretty much sums up all that I can really tell you about power supplies without going into load calculations and all of that stuff. So I hope this video helps you. And anyway, always remember to stay safe.